Hello, welcome to this afternoon's Monday stream. This afternoon stream. we're going to be testing some ray tracing functions. You know, I was going to do this right here, but I think I'm just going to do it in ShaderToy. So create a blank shader to start. Alright, so our buffer right here, buffer A is going to be where we're going to ray trace, and we're going to display it in image. That's buffer A going into itself, then image displaying buffer A. So this will just be O texel fetch, I channel 0, IVEC2U. Alright, so now the actual difficult part, and not really that difficult, is the ray tracing. We're going to do completely diffuse ray tracing for this test because it'll be easy to see what is happening. We're going to split the screen into two. So we're actually going to, I actually lied, we're going to do two buffers. One with one noise function, one with the other. So we're going to write the code in common. As a define. Oh, my cat just burst in the room. Hello, cat. Good looking. This is my tortoiseshell cat. Daisy. Daisy. We call her the princess. Alright, so how am I going to format this? So I'm just going to write the ray tracing code now. I'm actually just going to keep this as main image. So the ray tracing code is going to be in here. Ray scene is going to return the distance from array position and array direction to the hit on the scene. Otherwise, it'll return view distance. Hold on, I'm just gonna close my door now so my other cat doesn't come in here too. Is my mic lower or something? I don't know, whatever. Alright. So our scene is going to be super simple. We're going to split it into objects. Create a ray sphere function. And with the radius. So this does the ray position relative to the sphere. And I've actually found that doing a like 3-step ray trace is actually more efficient than the ray to sphere function. Can you hear my cat sneezing? Oh, Daisy. Alright, so distance equals RP minus radius if d is smaller than epsilon. Alright, awesome. So now ray floor. I should do this with a define. So now I'm just making a macro so that I can create a bunch of these ray marking functions really easily. There we go. So now this ray sphere function just becomes ray mark 3. Hey, said who? I'm testing a ray tracing noise function. I'm gonna see if I can get golden noise working or something better than white noise. Because the blue noise textures, it lost like 6 to 7 FPS. Sometimes up to 10 FPS with the blue noise texture. Because apparently sampling textures is really slow in WebGL. So I'm still trying to find something better. So I'm trying to find something that isn't even necessarily noisy, it just uniformly samples over time. And I've also been meaning to do this different kind of ray marking for a while, where you just, instead of doing all the objects in one distance function, and then tracing that with a whole bunch of iterations, you trace each object separately with a small number of iterations, because things like spheres don't have any edges where it's going to need to ray mark past. Like if you know that ray marking slows down right at the edges of things, if you just do one object at a time, it never has to ray mark past the edges. So for simple primitives, it's actually really good. Alright, let me test this. Ray scene. Return ray sphere. Oh yeah, so I'm setting it up so that it'll be a test where you have 2 ray marked scenes and 2 buffers, and then you can slide between them and they each have different noise functions, so you can see which one converges better. So basically I'm trying to program it so that all the main code is in common with like a macro or something, and then I can just have a little like option that switches between these two. I think I'm going to need to do it in a macro though. Why are academic papers costing so much? I don't know, I've literally never paid for a paper. I only use free papers. Or public domain ones anyways. Because if the paper has a license on the algorithm anyways, or a patent, then fuck that. I guess I'll just call it test. Oh god, this code's gonna be so ugly. Whatever. Back 3. Ray position starts at like -3 just for this test. Ray direction. Normalize vec 3. Aspect correct to the UV. Point the ray direction forward on the Z. Alright, now I'm just going to do super simple lighting to begin. So if distance smaller than view distance, then it hits something and we'll output green. Otherwise we'll output black. What are you working on, said who? You still fixing up the graphics for the Redstone builder? Still on pathfinding. Oh, nice. So there we got our sphere. It's pretty weird. Any part specifically that's weird? Oh, there's like no writing on it, at least that I can find. Well, there's so many different ways to do pathfinding. It's like, which way do you want to do it? I want a special case where it's a grid and I know the size. Isn't that like A sharp or A star? A sharp is too slow. Is there D star now? Oh yeah, there's D star. Yeah, they're incremental though, which makes them not work well in shaders, I think. Alright, I think this will work. It's bigger than 0, return that, otherwise we're return view distance. Minimum ray sphere, ray plane. Thought of a direction-based approach. If I describe it to you, you might have. I actually haven't checked your Discord since last night, so if you did post something about it, I might not have seen it. Alright, and I want this on the z-axis. Maybe I'm offsetting this wrong or something. Oh wait, no I'm not. There we go. So this should probably also return the normal, I'm thinking. Or at least like I need some sort of simple shading, I think. You move towards destination in the direction possible. Which dot product is closest to the direction to the destination. Only the directions are not hitting a wall or not. Huh. I'd be interested to see what you get working. Hold on, I'll be right back. I'm back. I'm interested to see if you get that working though. Man, you know what? Ray marking really is the easiest way to do this. Screw this custom format. So if you have 2 points A and B and there's a wall in between it, we'll run to it, then go either to one side of the wall or the other. then go to the destination directly after it's over the wall. Ah. But what if there's a wall after the other wall? Needs to be a kind of waypoint list. Yeah, I'm interested in your idea of like a direction field though. Of like vectors of which direction to travel. Awesome, okay. Now I just need, I'm basically copying the exact same format of the marble tracer right now. This outputs the material. Alright, now I just remark the scene. So I can just do that right here. In a loop. I think I'm going to do the same scaling epsilon as well. I should just copy the marbles code. What am I doing? I'm basically rewriting the exact same code. This BRDF function is actually the key thing where I have the random value. Oh man, I really don't like putting this in a define. It makes it so hard to type. If only there was a way to... easier way to do the defines. Oh my god, there is. So I can just do vec4 render vec2u. Just do this exact same thing. The one thing I do need is this rotate function. And you know what, I'm going to take the hash too. Alright, so render CUV, this is aspect correct UV. Rotated by the camera yaw. Oh wait, that's switched around. That's the pitch. This is the yaw. Camera position is going to start at -1 on the Z. And also because this is going to be a full path tracer. It's actually going to jitter the UVs here to do temporal anti-aliasing, but I'm not going to do that yet because I want to keep it as simple as possible to start. I just got to keep rewriting this. RD. I also need to declare the ray position, which starts at camera position. Alright, and then this Marbles in browser uses the already traced depth. Instead, what's going to happen is we're just going to go like this. And this is temporal reprojection. We don't need that either. And that does the background, which we're going to have no background right now. The background's going to be 0. So L is the accumulated light for the ray tracing. Replace this with epsilon. This with iterations. Alright, that should be good. Probably gonna have an error, yes. Distance. Oh, I forgot to copy over the calculate upright. I resolution, undeclared identifier. Did I spell I resolution wrong, or? I must have. I resolution is a declared identifier. I resolution right here. Copy I resolution. What? I didn't spell it wrong. Wait, what is going on? Turn is not matching type. Oh, there's no test variable. Oops. So this is supposed to be like define test void main image. Out vec4o in vec2u. And then at first I'm just going to output the rendering. Yeah, so I resolution undeclared identifier. Can you actually not use... I'm so confused. Wait. high resolution. If I replace this with a define, does it work? This is weird. I've never had this issue before. Like, seriously, what is happening right here? U times 2 minus I resolution divided by I resolution.x. I resolution undeclared identifier. Did Shader Toy change something and I'm like not aware of it, or? Whatever. I'll just pass this as the center UV. How the hell is I resolution not defined? Now it works. Oh my god. Alright. It sucks, there's like no easy way to know what Minecraft does. iTime undeclared identifier. What the hell? Can I not access any of the uniforms? Shader Toy can't access uniform in common. Sucks, there's no easy way to know what Minecraft does for power propagation. I think you could look at the source. Why don't you have access to any of the uniforms in common? It needs to output these uniforms. Why doesn't it have the uniforms before common? Like, seriously, what? Like, what if I declare this myself? It'll probably give me an error, right? It gives me an unknown error. You should totally be able to put this in common though. There's no reason for them to not put the uniforms above. Yeah, they have to use or pass the uniforms as arguments. Yeah, but like, why doesn't it just define the uniforms before common? Holy shit. This actually fucks everything up. Like, seriously. How in the hell do I pass this time variable to here then? Alright, I was originally going to do this in the shader view program, but I wasn't sure about it. Let me just test something. A lot of things I hate. Yeah, man. This site's normally too slow for me to use anyways. I have a thing called define default API iChannel 0. What does your define default thing do? I believe the includes in mine work properly. Include.text turn test GLSL. Yeah, so mine supports includes. Defines functions for reading and writing to the buffer. The reading and writing voxels. Ah, true. Stupid defines though. I don't want to use defines. Hold on. I think there's an ant crawling in my room. I gotta kill it. It crawled under my desk before I could even kill it. God damn it. Now I feel like it's gonna crawl up my leg. Yeah, you know what? Screw this. I'll just do it all in each buffer. Okay. So now if I actually add, if I make the sphere emissive here, if p.x bigger than 0, diffuse.w equals 0, why did I set it to 0? I'm not even thinking. Man, I'm actually fucking scared of this ant now. I'm not scared, but it's like, I want it to bite me. Wait, I'm an idiot. This isn't gonna build up samples. I didn't even set up the main part of the ray tracing. Alright. Man, it annoys me when stuff like this doesn't work as good as it could. Alright, I'm gonna add up the samples. So O was Texel fetch, I channel 0, I like to U 0 plus. And I've been thinking maybe integers would actually be better for converging than this. That might be something to test later on. So I'm not going to do B yet until I have A working. Okay, it's pointed the wrong direction now. At least I thought it was. So if Z by default is pointed 1, starts off at -3. Where's the plane? So the sphere's at 1. Plane's at P dot Z plus 1. The material. Oh, so right here I actually have to check if the P dot Z is bigger than -0.9 or something, or 1 plus epsilon. I gotta let my cat out. Not sure why this isn't working right now. Unless the camera is pointed around the other way. No, it doesn't seem like it. What could be going wrong here? Distance, ray position plus equal ray position. position equals camera direction. I don't know what the hell is happening. What is going on? Maybe something wrong with my normal function? I don't know. No, it's not that either. Distance p dot z plus 1. That makes the plane at -1. 1 at 1e -4. 64 iterations. What is happening here? What if I just gave everything a little bit of a mission? Then it would be staring at a missive. I gotta figure this out. I think it's something with my material then, because this seems to be tracing fine. So with this emitting light, I don't know what is happening here. I don't know if the compiler might be optimizing this out. It's bigger than 0.99. Maybe it's the minus normal times distance. My best guess so far is the normal function. What if right here I just return the normal? So there's no sphere. For whatever reason, there's no sphere. Oh my god. This is supposed to be negative p dot z. Plus 1 point. There we go. That wasn't too hard now, was it? Oh, and the ray looks like it's intersecting the surface a little bit. So we're going to do it with no dynamic epsilon, so that everything is as accurate as possible. Oh yeah, so it is the wrong way. So there we go. There's the lighting. Camera a bit farther away. So this actually is a broken BRDF. It's hard to see. Actually, it's easy to see here. The fact that this is in a square and not in a circle. So before anything else, we gotta fix the BRDF. Oof. Square light from a circle light. Damn. That's not very good. So let me see if just doing OD equals random dot XYZ if dot normal smaller than 0 flip that. That is also a square. How to fix this now? So the issue is directly in the distribution of the rays. Maybe it's something to do with this normalization. I don't know. What the hell? There's another ant. Wonder if ants are getting in somewhere now. Okay, let's figure this out. I actually have some old code that I believe does this correctly, but I kind of want to try it myself. I believe the trick is just cosine normalize. I don't know. Let me look at my profile. One of my old path tracers has it. polar to Cartesian, I believe is what I'm looking for. Oh yeah, this BRDF is way better. This is a cosine weighted BRDF. Cos theta, sine theta, phi, polar to Cartesian. Normalize LBR times. So this is the exact same thing, it's just using polar to Cartesian. And then reflecting the view off this direction. Let me copy this. And how is this different than this? Let me look. I'll need to see how these two are different. I don't think these are that different. It's adding the same ones, it's just not reflecting. is random -1 to 1 ERDF #13 #13 return -1 to 1, no, 0 to 1, okay. So now I need to do the polar to Cartesian. Oh, that's a really bad function. Maybe it is supposed to be reflect view. Well, it's exactly the same. Looks like Polar to Cartesian. Looks like it has some issues, at least on one axis. Makes me wonder, is the random value correct? Oh, Rand is the first one. Hash 33. Nope, that's still 0 to 1. Oh, that's supposed to be pi 2. Oh my god, it works. And I had it completely wrong. Well, I'm glad I figured this out. This will probably make the path tracer look way better itself. It's 1. Oh, this is awesome. This means I can do it like both of these in the same one. Let me just try reflect RD. Yeah, so the same thing, just a different roughness value. That's awesome. Sick. Okay. Now that we know all of this works correctly, I'm going to balance the color correct so that it's not too bright and not too dim. Oh yeah, I can also still apply gamma correct too. Alright, so this gives us a good idea of how noisy it is. So we're looking for a noise function that converges and looks way better. That's what we're trying to do. So I'm going to copy the code. Over, and what we're going to do is we're going to try to change the hash function to look better. So then so we're going to have divider for the screen. It's going to start up at half the screen. If the mouse is pressed, then the divider is going to be set to the mouse position. Right here I'm just drawing a gray mark for the divider. And then if the X is past the divider, then we're going to draw the B buffer. So this lets us compare so it's a reset. Let's set this hash function to something like the blue noise texture. I'm going to do texture LOD so it doesn't sample any maps just in case. Doesn't seem to be sampling evenly. It makes me wonder if this has a gamma correct applied to it. Maybe if I do POW or 2.2. It's still. I'm actually confused what's happening here. Maybe my seed values here aren't good enough. Like, why is this texture only returning? Oh, because it's grayscale, it's not red, green, blue, A. Yeah, and even this one is biased towards that direction. What the heck is going on? Do these have gamma correct applied? This is freaking weird, man. Why is it returning less light up above right here? Well, this is confusing. Hash equals this plus time. Maybe I need to increase time in this. Actually, though, what is happening? Something to do with texture LOD? Oh yeah, it's not scaled up enough. Actually confused how this blue noise one is worse. Different, but it's the same. I'll be right back. I'm gonna go and get some water. Alright, let's try and make a better noise function now. Let's try and find golden noise based on the golden ratio. Okay, let's see. This is actually gold. This guy lied. His noise function doesn't have superior distribution. That's horrible distribution. That is terrible distribution. Oh no. Let's see if we can't get a better noise function. I don't know about the golden ratio, but I believe in pi. So let's try that. Turn, fract, vec4. How am I going to do this? A dot product for each component. Well, that's interesting. It's actually got a pattern to it, which is kind of good. That dither pattern could mean uniform sampling. If I can roll it right. I'll go without absolute values. actually almost converging the same. So it's interesting. This bottom half right here is actually converging like exactly the same, even with the bad pattern. Which makes me think if I get a good pattern going, something besides fract. What if we just multiplied by pi again? I think the issue is that these basically match up when they're all multiplied by different values. I also wonder what these white spots are that show up. When it's rendering like this, it doesn't actually seem to be adding up to the buffer, it seems to glitch it out. I wonder if this is a new bug in ShaderToy, I haven't actually seen this before. And it only happens when it's paused. Anyways, I'm going to try increasing the scales here even more. Hey, said who? Have you got any more progress on the pathfinding? Are you ending stream? Wait, what the fuck? How did I get to the endings? Thanks for pointing that out. When did I... Oh man, fucking OBS keybinds. I must have accidentally pressed the keybind. Alright, so this one seems to be a tiny bit better. It's buggy right now. Share it in Discord. I'm in Discord right now. Oh yeah, you have no pathfinding thing yet. Oh, look at that. Where is it going? Is it going to here? It's not working. It works until you get this certain block away. Pathfind. Yeah, it actually doesn't work. And it's hard to tell, so also you should make it draw the red over the yellow or something, because like here, it's actually kind of hard to tell if it's stepping through the yellow. Nice though. Making progress. Alright, I'm going to start trying this without a hash function. So my idea is that because of the way this works using random x and y to basically twirl around in the different angles, if I twirl around those over time, for example, if I do constant random dot x and then do random y as time, frac time, it should go around, yes, just like that, go around on the one axis. So my theory is to do uniform sampling. All I need to do is do something that's like, just like how you do 2D sampling of an image from one dimension, I would do for the y, I would do floor I time. And then for the x, it'd be I time minus rand.y. Just be fract actually. So then this would be fract floor I time divided by something like 100. Oh, so now that's drawing it step by step, outwards and in. That's so interesting. Oh man. So if I speed that up, the guy times 100. So that's more biased in one direction than the other. It looks like a flower. I made a flower. Maybe if I multiply it by time, it'll be more random. Otherwise, it's going by the same values each time. Yeah, so I need to get it so that it's decently uniformly distributed. Oh, so the other issue is whenever it's hitting, it's going off in the same direction, because this is just based off time, not also based off direction. I still think the noisy sampling looks better in this case. And it's actually not matching up in terms of brightness. I don't know if it's because it's not sampling the middle or something, but is it using the random Z anywhere here? I don't think so. I think it's because this is divided by 100. So basically I'm looking for something that will converge to a better result over a long period of time. As you can see, the noise kind of has some issues over time. It basically stays noisy off to the edge here. So I'm looking for some uniform sampling function like this that'll get smoother over time. Problem is the brightness isn't matching up, at least in this one. Yeah, so that's a failure, I think. I have an idea for making the noise converge better as well. Still, there should be some way to search all across time like this. Even just doing different phased. That actually looks like it's working a lot better. Oh, I know why it's not equal in the middle, is because it's not doing the bounces either. I think this will even out better over time because it's not noisy. Instead, it's more like fractured. It has like these spots, which I think might be better. Now, if I can get it to bounce, and still transfer its position. I guess if I'm lazy, I could just do hash position. Such a hard problem. That's why I said pathfinding and shaders, man. It's like really difficult. And you know what I realized? Because this is actually quantized, you could think of these petals, block shapes as quantized. I could apply blue noise after this. It would actually work better than the noise. Alright, now I'm just gonna make it bounce somehow. Well, that's an interesting pattern. Not as bright. You can tell it's not bouncing the same because it's not, doesn't have the same brightness there. But it does look damn smooth. Almost has like a blue noise pattern. I wonder if this is from the time pattern. Oh, it's somewhat equal now. Still not filling in these far areas though. Gotta get rid of these artifacts here. This is a horrible system. It's doing the exact same patterns each time. Alright, that's less noisy. That is amazing if I can get this to work. Oh, I just need to get rid of these spatial patterns. Maybe I'll just try the tried and true method of making numbers way bigger. Looks like it's working. You can still see some distortions though. If I can get past those distortions, I'm fairly positive it's less noisy. The other thing I'm interested in doing is the integer storage. If I store the rendering as an integer, then it would have much higher precision and it wouldn't run into floating point precision issues when it's tracing tons of paths like this. So I think I'm going to do that before I go any further. So to do that, I believe I'm going to want to encode it as unsigned. I can just use IVEC4 actually, I think. Let me check the documentation on this. Int bits to float. Okay, so IVEC4 value is render. We'll take render here, we'll convert it to quantize value. We're going to do 6-bit, which is 32. Okay. So that converts to an integer. Then I need to decode the last frame's integer value. And I'm going to need to decode the... Oh, wait. Actually, so first of all, when it's frame 0, I should reset the frame to empty. I'm not doing that, and that's something I should do. Int bits to float. Alright, so now spec for old value, fetch this value. So then what we have to do here is we have to convert this to an integer using the float bits to int. So this will be, I'm actually should create a macro for this. Integer convert float value float to integer. Float bits to int f. Alright, so our sum value is doing all these conversions. And then adding that value here and 1, and then we need to convert it back, which is integer to float. So then after we add this, we just convert back and output it. So we do I to float sv.x, I to float sv.y, I to float sv.z, p.w. Wait, actually, I didn't even check if this worked with batch. It's to int. Oh, it does just work. I'm an idiot. Oops. So I didn't need to do all of those batch conversions there. I could just do ivic4 sv equals float bits to int. And then here we need to decode that value. Float bits to int. So I'm going to convert that back to a float by doing b.xy times 255 there's going to be vec3 b.xyz times 255, 256 minus the total, which is in w, and then converted to a float. Or actually multiplied by quantized value Actually, that'll already be quantized. I can just do divided by W, then divide by quantized value. Then O.W equals 1. Alright. I think there's an overflow glitch or something, because it's turning pixels to black. That's weird. Oh, I think it's due to quantization. The light values go over 100. I think it might actually be overflowing. Hey, said who? Maybe I actually need to lower the light values. I'm eating this right now. Yeah, that sometimes happens. Am I doing this right? Render float bits to int. Plus IVEC4. Into bits to float. I don't know. I don't know what's happening. And float bits to int. Quantize the int. Divide it by the quantization value. If I do absolute value of this, does it fix it? No, it's just as the W goes up. Maybe I actually need to increase the quantized value. It's really hard to tell if it's just quantizing right here. I think it starts to overflow though. I think floating points are better. Can you help me figure this out? Maybe. I kind of got my own stuff I'm trying to figure out right now. Dead right now. Maybe get more energy then before you work on it. I always run in circles if I try and do something when I don't have enough energy. I'm actually not I'm thinking I'm not going to get anything better than a hash function. Looking at this. Found an angle-based path planning algorithm the other day. Now I lost it. If I were you, I would look at one that just works on blocks and doesn't take in normals or directions or anything. Oh, so this algorithm converges alright, but it still has those patterns. Telling path that is non-existent if I hit a wall, though. Doesn't stop there. I just realized this is on a black screen. God damn it. I'm kind of dead now, too, now that I think about it. Alright, looking at this, though, this is 100% more uniform and better. If I can, or it's not uniform, you can see the distribution is wrong based on that stuff right there, but if I can get that, then it'll be a less noisy tracing. So I tried just increasing this to way larger until it basically is noisy. And wait, that actually works. What the hell? That actually worked. And it does seem to be slightly less noisy. Like, actually less noisy. Holy shit, let me take a print screen of this. Alright, this part right here is definitely more noisy than this part. Look at that.
In 2072,
This is definitely less noisy.
known as Shodan, lost her mind. In her limitless imagination,
Let's do a Gaussian blur test.
as a goddess,
So sing 2 steps of Gaussian blur.
that image was snuffed out by the hacker who created her.
Yeah, so this is definitely less noisy. Oh my god, that's amazing.
February 3rd is the day the magic happens. The Von Braun, the first starship in history.
So I actually got a better random function. Fucking Pog.
This incredible journey is the result of teamwork between the UNN Protectorate and the incredible scientific minds of the newly relicensed Tri-Optimum Corporation. Imagine being able to travel
I think I can still make it better. Black screen.
part of Tri-Op's commitment to the future. The Von Braun is packed with over 1.8 billion flight.
No, it's not. You trolled me.
Nearly all developed by Tri-Optimum and its wholly owned subsidiaries.
Unless the stream's out.
Security for the Von Braun as she plows through the heavens will be the UNN Rickenbacker. At her helm will be no less than
Does this get captured too? Yeah, everything's getting captured.
Battle of Boston Harbor during the Eastern States Police action. This incredible
Steady yourself, soldier. This is Dr. Janice Polito of the computer ops staff of the Von Braun. You're safe for the time being. You're recovering from the effects of surgery and will be unable to remember any of the events of the last few weeks. You're on board the starship Von Braun and something's gone very, very wrong. Some kind of force has hijacked this ship. That's why you volunteered to be implanted with some experimental cybernetic implants. Rely on your cyber interface. It just might save your life. You must find an elevator and come up to Deck 4 to meet me. Deck 4. Can you remember that? But keep your eyes open. They're after us both now.
If only I can find a way to make this better. So I think maybe S position times equal S position. That's an interesting pattern. Is the stream actually outputting a black screen? Let me check this. No, not anymore, thank God. So I'm going to do S position times S position for this part. So that converges really well. You can see there's a little bit of artifacts though. Maybe for this seed position, if I did fract, if I did something different, like the fractional part of these values divided by some large numbers. See if that evens out. Doesn't look like it's going to even out. Oh, it is evening out. That's actually damn smooth. The issue is, of course, it has distortions, or not equal distribution. Yeah, I think this noise function, I'm pretty positive this is actually a better noise function. It's less noisy, which is actually incredible. Woo! This was a success. We got a better noise function. So now we need to apply this to Marbles in Browser, or Marble Race, and we need to do a little bit of polishing. But I am kind of dead and tired. I just need to check this. I need to make sure it's good. Seems like a really good noise function, like too good to be true. Whenever I see a really good noise function like this, I just go, okay, so what's wrong with it? Because there has to be something that makes it not perfect. So far it seems pretty good with minimal distortions around. But that's going to be the end of the stream here. Man, I can't wait to get done with Marble Race. Well, what I want to do is I want to get to a point where I can just work on a little bit of courses each day. Use it as like a place to test out path traced scenes and things. But anyways, thanks for watching. If you want to continue this discussion, we can talk in the Discord. The link's below. My shader toy link is already there below. Is also there below if you're interested in any of these shaders I programmed today. But yeah, everyone have a good day. I don't think I'm going to stream tonight, so I'll see everyone tomorrow. I'll be live again at like 10 a.m. EST. Do more game development on Marble Race. And I'm going to do a game jam at the end of this week on Friday. So I kind of want to get everything ready for my C engine. So we're probably going to be finishing up Marble Race, and then we'll be focusing on C programming for like the next 2 or 3 days. So that should be fun. See you guys around. Have a good one.